All right, now it's time for ITTOs. First, the inputs. In it, the first one is project management plan, which is obviously means components of project management plan. Here we have two components. Let's look at those. First, schedule management plan. To sequence the activities, you need the method to be used, level of accuracy required, and other criteria required to sequence the activities, and schedule management plan will have all those information. Second, scope baseline. While defining the activities, components of scope baseline, such as the project WBS, deliverables, constraints, and assumptions, are some of the key inputs. The next input is project documents. There are four in it. Let's look at them one by one. Activity attributes. The activity attributes, such as predecessor, successor, impose date, resource assigned to, etc., will be helpful to sequence the activities. Activity list. To sequence the activities, you need to have the list of activities, their dependencies, and other constraints which can influence the sequencing activities. Assumption log. Assumptions and constraints recorded in the assumption log may influence the way activities are sequenced. The relationship between activities and the need for lead and lag will have influence in sequencing the activities, so you need to consider them as inputs. Milestone list. The milestone list may have scheduled date for specific milestone, which may influence the way activities are sequenced, obvious, right? The next one is enterprise environmental factors. Government or industry standards, for example, product standard, quality standards, safety standards, and workmanship standard will have influence. Organization work authorization systems, project management information system, scheduling tools are some of the enterprise environmental factors to be considered as input. The last one is organizational process asserts. Existing formal and informal activity planning related to policies, procedures, and guidelines, such as the scheduling methodology that is considered in developing logical relationship. Lessons learned repository containing historical information that can help optimize the sequencing process, portfolio and program plans and project dependencies and relationships. The templates can have information that are related to project activities, activity attributes, and other information can help in sequencing the activities. All right, now let's move to tools and techniques. The first one is precedence diagramming method. The precedence diagramming method, PDM, is a technique used for constructing a schedule model in which activities are represented by nodes that are graphically linked by one or more logical relationship to show the sequence in which the activities are to be performed. PDM includes four types of dependencies or logical relationships. A precedence activity is an activity that logically comes before the dependent activity in the schedule. A successor activity is a dependent activity that logically comes after another activity in the schedule. Let's look at four types of relationship one by one. First, finish to start, FS relationship. A logical relationship in which a successor activity cannot start, here activity B, until a predecessor activity, here in this picture, activity A, has finished. For example, installing the operating system on a PC, the successor activity cannot start until PC hardware is assembled, which is the predecessor activity. The next one is finish to start relationship, FF. Let's look at the picture. Often people get confused that activity A and activity B must be completed at the same time is called finish to finish relationship. Not really. It's the logical relationship in which a successor activity cannot finish until a predecessor activity has finished. Let's take an example. I'm sure we all traveled in taxis, right? Here, let's say you want to travel from point X to point Y, that's activity A. And the taxi driver's activity is activity B. Unless you finish your travel, that is reaching from point X to point Y, the driver's activity, activity B, cannot be called as completed. The next one is start to start relationship, yes. Let's look at the picture. Just like in finish to finish, it's a logical relationship in which a successor activity cannot start until a predecessor activity has started. One of the examples could be, we all watched live matches, right? Let it be soccer, tennis, cricket, or any such game. Let's say you work for an organization that live telecasts this match. You cannot start the telecast unless the match starts. You have to wait until the match starts. You may be ready with all the equipments, but still, you cannot start the live telecast until the match starts. So that's start to start relationship. Now, let's look at the next one, start to finish. Again, let's look at the picture. By the way, all these relationship pictures are taken from the PMBOK guide, figure 6.9. Okay, let's continue to start to finish relationship. A logical relationship in which a predecessor activity cannot finish until a successor activity has started. One of the classical example is new software development. Let's say you want to roll out a new accounting system. You cannot roll out unless the old accounting system is shut down. Otherwise, you will end up in having two parallel systems which will cause confusion. Other very important point to remember related to relationship. Generally, multiple relationships between the same activity are not recommended. So, a decision has to be made to select the relationship with the highest impact. The next one is dependency determination and integration. Dependencies can be characterized into four attributes: mandatory, discretionary, internal, and the last one is external. With the four above attributes, they can be applied in as mandatory internal, mandatory external, discretionary internal, discretionary external. Let's talk about mandatory dependencies. The synonym for mandatory is compulsion, must. So, a mandatory dependencies are the dependencies that must be there. Depending on the nature of work, dependencies are legally or contractually inherited. Mandatory dependencies are often physical limitations. Some of the simplest examples are: for building, you cannot build a structure without a foundation. You build the product, then you do the testing. The mandatory dependencies play a vital role while sequencing the activities. The project team determines which are the mandatory dependencies during the process of sequencing the activities. Mandatory dependencies are sometimes referred as hard logic or hard dependencies. Now, let's talk about the next one, discretionary dependencies. Synonym for discretionary is optional or flexible. It's not mandatory to follow the discretionary dependencies, but the sequence is identified based on the best practice. So it's preferred to follow the sequence. The specific sequence is desired even though there may be other acceptable sequence exists. For example, during construction, it's preferred to complete first the plumbing work, then the electrical work. Both the work can be carried out in parallel, but based on the best practices, it's advisable to perform in sequence to reduce overall project risk. Discretionary dependencies should be fully documented since they can create arbitrary total float which can limit scheduling options. When fast-tracking techniques are employed, these discretionary dependencies should be reviewed and considered for modification or removal. Discretionary dependencies are sometimes referred as preferred logic, preferential logic, or soft logic. All right, now let's talk about the external dependencies. External dependencies involve a relationship between project activities and non-project activities. These dependencies are usually outside the project team's control. For example, testing activity in a car project may depend on the delivery of testing equipment from an external source. The project management team determines which dependencies are external during the process of sequencing the activities. Let's talk about the internal dependencies. Internal dependencies involve a precedence relationship between project activities. They are generally inside the project team control. For example, the team cannot test a machine until it's assembled. The project management team determines which dependencies are internal during the process of sequencing the activities. Now, leads and lags. We already discussed about it, so let's have a quick recall. Lead is something which goes in advance than the normal. Lag is something which is delayed. After the completion of predecessor activity, the next activity cannot be started immediately. The successor activity has to wait for a certain period of time. The last tools and technique in the list is project management information system. We are in sequence activities, so the project information system that are relevant to this process includes scheduling software that has the capacity to help plan, organize, and adjust the sequence of activities, insert logical relationship, lead and lag values, and differentiate the different types of dependencies. All right, now let's look at the outputs. The first one is project schedule network diagram. A project schedule network diagram is a graphical representation of the logical relationship, also referred as dependencies, among the project schedule activities. A project schedule network diagram is produced manually or by using project management software. It can include full project details or can have one or more summary activities. This helps to arrive at a basic approach used to sequence the activities. Activities that have multiple predecessors indicate a path convergence. Activities that have multiple successor activities indicate a path divergence. Obviously, activities with divergence and convergence are at greater risk because they are affected by multiple activities or can affect multiple activities. For example, in this picture, activity I is called path convergence as it has more than one predecessor, while activity K is called as path divergence as it has more than one successor. The next output is project document updates. Here we have 4 documents that are updated. Let's look at them one by one. First, activity attributes. Think for a while, what will you have as an output after activities are sequenced? You will have the activity attributes such as logical relationship between activities and lead and lag of activities, right? So obviously they need to be updated. The next one is activity list. You have the list of activities to be done. In case if the relationship between the activities got changed because of sequencing, then the list of activities to be carried out in the project also goes for a change. Of course, there may be new activities which can change the already listed activities. So you need to update them as well. The next one is assumption log. Just like in Create WBS, after sequencing the activities, you may realize that few more assumptions to be added, existing assumptions to be modified or deleted. The last one is milestone list. The scheduled date for a specific milestone may be impacted by changes in relationship between the project activities during the sequencing activities. So you need to update it. All right, that wraps up the ITTOs. Let's move to the next process.